Hello everyone, I'm Siying. I'm a master's student with Dr. Sue Peters from the Neuro Rehab Physiology Lab. Today in my talk, I will introduce my project, which is discovering cortical activation changes after functional electrical stimulation cycling in patients with stroke. To begin with, let's talk numbers. Around 50,000 people in Canada have a stroke each year, with 300,000 people living with the effects of stroke. Complications of stroke affect people. Some common complications are muscle atrophy, fatigue, and memory loss. We all know that rehabilitation is important for stroke, but have you ever thought about brain rehab or the connection between the brain and the physical body? So today we're not just talking about the physical side of things, but we're also looking into the brain. Our powerful brain uses trillions of cortical connections to send and retrieve information. When we look at brain after stroke, some of these cortical connections may be lost and brain damage caused by stroke cannot be reversed. However, there is a process called neuroplasticity that can help rewire lost functions to new, healthy areas of the brain to compensate for the damage after stroke. For example, a right hemisphere stroke may cause impaired sensation on the left side of the body because the right somatosensory cortex is damaged. To overcome difficulties, neuroplasticity allows the brain to create new cortical connections elsewhere in the brain that control somatic sensations. This is amazing, right? Because for some patients, neuroplasticity is how they may regain lost skills and regain their independence. Now, knowing that neuroplasticity is amazing, how do we activate that for our patients? Recent studies suggest that aerobic exercise completed on a bike can aid with neuroplasticity in healthy adults. So maybe bike-based exercise can be an alternative for patients with stroke. Specifically for this pilot study, we're choosing to experience with functional electrical stimulation cycling, also known as FES cycling. It is a stationary bike with a computer that supplies electrical impulses for contracting major muscle groups, shown by the picture. We chose FES because it has shown efficiency in preventing spasticity and strengthening muscles. But sensorimotor outcomes and somatosensory recovery is rarely reported. FES could be used for upper and or lower extremity, but since lower extremity FES rehabilitation is much less looked at, we're going to look into lower extremity only for this study. To measure cortical activation changes before and after cycling, we will use functional near-infrared spectroscopy, also known as fNIRS. It's a non-invasive and useful neuroimaging tool to assess cortical activation by observing oxygenated and deoxygenated hemoglobin levels, which are two direct indicators of cortical activation. We're going to place the device on bilateral prefrontal cortex, which are commonly active with lower extremity movement in healthy adults. After placing the fNIRS device, we're going to perform 3 tasks. Somatosensory stimulation of the ankle using a safety pin, active ankle plantar and dorsiflexion, and passive ankle plantar and dorsiflexion. So to summarize, after admission, we're going to collect fNIRS data with these 3 tasks. Then patients will go through FES cycling therapy for 8 to 12 sessions, and then we will collect fNIRS data with the same task again at discharge. Now that you know every aspect of my study, I will restate the aim of the study in details. It is to discover if cortical activation changes in bilateral prefrontal cortex are associated with sensorimotor stimulation before and after FES cycling in patients with stroke. Even though we haven't started collecting data yet, we're going to start in just a few weeks. It is expected that cortical activation will change at discharge compared to baseline, but we don't know the direction of change, which means any correlation could happen, and we're just so excited to find out. After this study, we can gain a better understanding of the brain-body connection, or more specifically, the brain and lower extremity connection, which hardly any study investigated. Thank you so much for listening. If you have any questions, please send me an email. I hope this study is interesting for you as it is exciting for me. Thank you.